How to achieve SSPC SP7. This class is technically not able to be achieved because as soon as you've blasted an A-grade mill-scale surface, you normally go straight to an SP6. But the blaster in this video is attempting to achieve as close as possible. An SP7 class of blast is a brush-off blast cleaning, and the technical specification calls for all loose mill scale and contaminants to be removed. As you can see, the blaster is simply moving the nozzle over the surface as fast as he can, removing all loose contaminants. All loose contaminants are removed as per the technical specification. How to achieve an SSPC SP6. The specification for SP6 is that in addition to having no loose mill scale or contaminants, the blast pattern displays no more than a 33% shading. As you can see, the operator is taking a little bit more time and care to ensure a cleaner surface than the SP7. You will notice there's approximately 33% shading on the steel. How to achieve an SSPC SP10. The technical specifications for the class of blast is there's a maximum 5% visible contaminants or shading. When trying to achieve SP10, the operator is paying careful attention to the blast overlapping his blast patterns. On the grade A steel, it is typically faster and better to use long strokes of the nozzle instead of going around in circles, as this will achieve a much more consistent blast. You will also notice in this video that there is minimal dust and the surface is very easy to clean. This is due to two reasons. One, the choice of abrasive. Secondly, the substrate. A lot of dust is caused by rust being on the steel. In this example, there is no rust to create dust, and also the abrasive being used is Speed Blast Australian Garnet, which is a very hard, cost-effective particle which can blast quickly and causes little dust. It is highly recommended when blasting grade A mill scale surfaces. What we have here is a snapshot of the blasted SP10 surface. You might say this looks like a perfectly clean surface, but there's actually very slight shading that you can see just above the inspector's finger in this inset photo. This makes this an SP10 blast, which has a maximum 5% visible contaminants or shading. How to achieve an SSPC SP5. SP5 is a white metal class of blast. There are 0 contaminants, 0 shading. Again, the operator is moving his nozzle slowly and in long, straight strokes, and he is overlapping the blast pattern approximately 50% to ensure that he gets a perfectly clean surface. As you can see, SP5 is a white metal blast. There are no contaminants and no shading. This is a perfectly clean blasted steel surface.
So in relation to this, the SP10, as you can see, look, this is what I'm talking about, the shading. The shading in this is uniform, it's neat. It shows me that my 5% really is negligible in relation to the substrate, primarily because the substrate is easy to clean. So as you can see, SP10 in this substrate, A, SP5 and SP10 are very similar, but again, as I said, the significance or the variation I'm looking for is the uniformity of colour and shading of the substrate. And you can see the variation here. We come to SP6, Now SP6 here has, again, look, on an A substrate is relatively clean. So when you look at SP6 as opposed to 7, look how easy 7 was to sweep that substrate. So you could actually do it slightly quicker on an A grade substrate for a sweep. But the point is that you can see here you've got your variations and shading that show through that to show that it has been swept. In conjunction to, there's less of this shading in 6 and even less in 10 and none in 5. So to achieve that type of result, a 7, 6, 10 and 5 on an A grade, so very, very easy, relatively quick.
How to achieve an SSPC SP7. Specification for SP7 is the removal of all loose surface contaminants. SP7 can be achieved with a rapid but thorough brush off of the substrate. The nozzle moves very quickly to remove all loose mill scale and contaminants. As you can see on this B substrate, SP7 has been achieved. How to achieve an SSPC SP6. The specification for SP6 is the removal of all loose surface contaminants, leaving no more than a 33% shading within the blast pattern. To achieve SP6 on a grade B substrate, the blaster also moves relatively quickly, but must ensure there is no more than 33% shading. SP6 requires a maximum of 33% shading differential across the substrate, and this has been achieved. How to achieve an SSPC SP10. The specification for SP10 requires a resulting shaded gray metal with only tiny isolated strips of visible contaminants. The blasted surface would have a maximum 5% visible shading. SP10 requires the blaster to be more deliberate with his blasting strokes, timing the flow of the nozzle to clear the substrate of corrosion and contaminants, and leaving a maximum 5% visibility of shading. Although close to white metal, SP10 allows a maximum of 5% shading differential across the substrate, and this has been achieved. How to achieve an SSPC SP5. The specification for SP5 requires a clean, consistent white metal blast with no visible contaminants or shading. Once again, methodical blasting and overlapping vertical strokes allows the blaster to clear the substrate, resulting in white metal status. Zero shading and zero visible contaminants are required for SP5 specifications. As you can see, the specifications for SP5, a white metal blast with zero contaminants and zero shading, has been achieved.
Okay, B grade. So the substrate again is nowhere near as significantly corroded as what the D grade was, and you can see that in the substrate. Now look at this substrate again. The substrate shows you that there is no pitting, everything is uniform. So as a class of blast, as we see here, a white metal blast, SSPC SP5, which gives you uniform, and the shading again, as I said, is all the same. So where it's cut and moved the substrate, it's cleaned it, there's no pitting, and the surface is uniform. So uniformity again. Here we are again. So we have SP10. So SP10, again, look at that. It's almost white. This is a white metal blast. This is SP10, is a nice uniform clean blast with how much shading? 5%. So 5% of shading is indicative to this substrate, and again, it is conducive to the standard. Our SP6 again is a commercial blast, so our percentage of shading again has reappeared because it's indicative to what the requirement is. So if we stay to standard, yes, we have areas of significance that have not been cleaned in conjunction to SP10, but again, you see, it's the shading we're looking for and the uniformity of blast in conjunction with the standard, and there it is again. So look here on the sweep, look how much cleaner the sweep is on a B grade substrate. So a B grade substrate, why is it cleaner in conjunction to the standard? Because a B grade substrate will cut and cleaner and easier than what a D grade will. So consequently, that's why the sweep comes up slightly cleaner. So as an inspector, you'll be very happy with a sweep on a B grade substrate.
How to achieve an SSPC SP7. Specification for SP7 is the removal of all loose surface contaminants. SP7 can be achieved with a rapid but thorough brush off of the substrate. The nozzle moves very quickly to remove all loose mill scale and contaminants. As you can clearly see on this grade C substrate, SP7 has been achieved. How to achieve an SSPC SP6. The specification for SP6 is the removal of all loose surface contaminants, leaving no more than a 33% shading within the blast pattern. To achieve SP6 on a grade C substrate, the blaster moves relatively quickly, but yet slower than he did on grade A or B. This is to ensure that there is no more than 33% shading. With less than 33% shading, substrate C specifications for SP6 have been accomplished. How to achieve an SSPC SP10. The specification for SP10 requires a resulting shaded gray metal with only tiny isolated strips of visible contaminants. The blasted surface would have a maximum 5% visible shading. With denser corrosion on a grade C substrate, to achieve SP10 with shading less than 5%, the blaster must move much more slowly than he did on grades A or B. As you will notice, he is methodically aiming his blast pattern, overlapping it to ensure that the shading is smooth and consistent throughout. As per specification standards, shading less than 5% makes this a valid SP10. How to achieve an SSPC SP5. The specification for SP5 requires a clean, consistent white metal blast with no visible contaminants or shading. To achieve a white metal blast on a grade C substrate, the blaster must move very slowly and much more deliberately, making sure there is overlap in its blast pattern. This will ensure that there is zero shading in the final outcome. All contaminants will be removed, and you will have a clean, consistent white metal blast. The blaster successfully achieved a white metal blast. Zero contaminants, zero shading. This is an SP5.
So you can see obviously here on the surface or the substrate that there's nowhere near the significance of pitting. Okay, it's variable and it's there, but it's nowhere near as significant. So what we're looking for here is the same as what we've done. SP5 here is nice and clean, uniform, and the same. We've achieved the same shading. So it's shading we're looking for. It's clean, all the pits are cleaned out, and it produces an SP5, which is a class 3 blast, which is very, very clean. You can see here again, okay, we've got our 5% of shading, but it's the shading we're looking for from this area to this area. So the blast has come through and he's cut the surface, but he's still got shading in conjunction with what the standard shows me. So as an inspector, I'll be looking for what is conducive or indicative to the standard, and this here produces the same result. That's what you're looking for. And you see the difference too in Class C. The pitting is nowhere near as significant as Class D. And again, here we have an SP6, which is a commercial blast. A commercial blast gives you something, and this is what you're looking for. It's indicative to standard. That does. It shows us that we've moved within the parameters of our sweep requirement or our cut requirement, but it still leaves us, has the same retention with nowhere near as pitting on the much pitting on the substrate. This one here is our SP7, which is just it's just a sweep blast. So you can see though, because the C grade is nowhere near as significant as D, your pitting's nowhere near as bad.
How to achieve an SSPC SP7. The specification for SP7 is the removal of all loose surface contaminants. How to achieve an SSPC SP6. The specification for SP6 is the removal of all loose surface contaminants, leaving no more than a 33% shading within the blast pattern. SP6 is a commercial blast and will pass inspection as long as there is no more than 33% shading of the blast surface. To clarify, the blaster does not need to hit 33% on the mark. 33% is the maximum differential that can be present to qualify as an SP6. Although it is less efficient and unnecessary, anything greater than 5% and up to 33% will qualify as SP6. How to achieve an SSPC SP10. The specification for SP10 requires a resulting shaded gray metal with only tiny isolated strips of visible contaminants. The blasted surface would have a maximum 5% visible shading. Like previous substrate grades, the blaster adjusts the speed of the nozzle with the goal of clearing the substrate to near white metal. Leaving only a shading of 5% or less is the intended goal, and so more focus is given to overlapping the blast strokes and consciously slowing down the process. How to achieve an SSPC SP5. The specification for SP5 requires a clean, consistent white metal blast with no visible contaminants or shading. As reiterated throughout this series of videos, it is the degree of shading that determines the flow of the nozzle and overlap of the blast stream. As SP5 is a white metal blast, and this D-grade surface provides the heaviest corrosion, the blaster must time the flow of the nozzle and abrasive so all contaminants and visible streaks are eliminated. More time is required to achieve an SP5 on a D-grade substrate than any other specification.
This here is SSPC 5, so this is a white blast. The white blast signifies an even texture, so when you look at a blast gradient, it's in relation to the shading. So as an inspector, you would be looking for the shading to be uniform, particularly in SP5. SP5 shows a white blast, so therefore there should be very little shading, and that signifies the type of substrate that you've blasted, because it should be all clean, uniform and the same pattern all the way through, which is indicative to this area here. You can see that it's all the one shade, it's all the one colour, and it's in conjunction with the standard as well. So that's a nice clean blast. SP10, which is a class 2.5 blast, which shows some shading, but by the same token you can see that in this D grade rust that the pitting has been cleaned, so you can still see by comparison to SP5 there is a variance in shading, which is conducive to a SP10 blast, but it's all uniform. So it's 5% we allow for variation, and that 5% is indicative to the shading. So when I say that you look at a substrate and to signify or identify the blast, you are looking at or looking for the uniformity in the shading and the colouring. So it's shading you're looking for. In SP6 you can see what I mean now. You see, even though the blaster has cut the substrate, he still shows here that it's all uniform, and that's important to your pattern and the way you apply the blast nozzle to the substrate, so that your blast is clean and consistent all the way through. So it's uniformity. So from here to here you can see it's a uniform colour, uniform pattern, and again it's consistent with the standard. So that's what you're looking for. So let's look at SP7. SP7, so how much residual can be left on SP7? It's important to understand that this is just a sweep. So as far as sweeping concerned, what have we done? Well, as you can see, we haven't changed the colour of the substrate much. More importantly, you've got still this uniformity about the surface that's been blasted, but you can also see here there's still deep pitting that is harbouring corrosion. So you've still got the pitting with corrosion in it. However, in these areas you can see here there's still some corrosion or corrosion layers build up here, but it's tight, it can't be removed. So what we've done by sweeping is we've removed all the loose stuff, and that's basically what you're looking for in a sweep. It's just removing all the loose stuff, but not removing the significant corrosion within the pit.